A very warm welcome to all of you. My name is Amar. I am from third year CSCA with register number 513. Today I am going to discuss about NFA with epsilon transition, which belongs to the subject formal language for automata theory. Here you can see with NFA with epsilon transitions, non-deterministic finite automata are powerful tool for pattern matching. In this presentation, we will discuss NFA with epsilon transitions in depth, exploring their uses, limitations, and implementations. Come to the next slide. Here you can see the introduction. What is finite automata? A model for identifying patterns in sequences such as text. And deterministic versus non-deterministic. In deterministic, DFAs are only allow one transition, while NFAs allow multiple transition. Why we use these NFAs? They can match pattern very faster than DFAs for certain types of inputs. What are epsilon transitions? Transitions that don't consume any input, allowing the NFA to jump between the states. How to use these epsilon transitions in NFA? Epsilon transitions can be used to make an NFA more expressive and powerful, since they can eliminate need for some complicated state transitions by the NFA. Here in the next slide, we are discussing about the limitations and challenges of NFA with epsilon transitions. Here there are majorly four. The first one is exponential behavior. The use of epsilon transition can lead to exponential increases in the size of NFA, making it computationally expensive and difficult to manage. And the second one is implementation complexities. The implementation of the epsilon closure algorithm is a non-trivial task and requires significant knowledge or graph algorithms. And the third one is finite state and regular languages. While powerful, NFAs with epsilon transition are not capable of recognizing some grammars that can be recognized by other automata such as context-free grammars. Here we all know that in the first state the grammar is represented as G equal to flower braces VTPS. V stands for non-terminals, T stands for terminals, P stands for productions, and S stands for start symbol, as we all know that. And the finally, fourth one, matching ambiguity. Because there can be multiple transitions from one state to another, the same input can produce multiple valid paths, leading to ambiguity in the obtained matches of regular expressions. Let me explain you in a simple way. I have taken an example for the same question I have done in a process that got the answer. And you have taken the same question and done in the same process. But if you are getting some other answer, then that's where the ambiguity exists. We are not going to accept that. Even how many persons do the sum or do the problem, the answer or the final input or output must be same. But here it does not exist. And we can see the examples of NFA with epsilon transitions. The first example is checking URLs. Second one is regular expressions. And the third one is lexical analysis. Let me tell you in detail. Epsilon transition can be used to check whether a URL is well formed without having to worry about complicated state transition. A complicated state transitions in the sense when a URL is clicked or tapped on it, whether it is navigating successfully or not. That's where it comes. And when it comes to the regular expressions, NFAs with epsilon transitions can be used to implement regular expressions with fewer states and transitions. If you are in a situation developing a solution for the problem, if the solution contains 100 steps, no one are going to accept it, right? Sorry, it must be minimal and optimal. So we can use regular expressions. And the final one is lexical analysis. NFAs with epsilon transitions can be used to identify keywords or tokens in a piece of code, streamlining the process of lexical analysis. Here comes the conclusion. NFA with epsilon transition can be powerful and efficient way to match patterns and process data. However, it's important to keep in mind the limitations and challenges associated with these automata to make the most of them. You'll need to carefully evaluate whether they are the best tool for the job and have deep understanding of their implementation and usage. And that's it about the NFA with epsilon transition. And thank you. I hope you got it.